This is Higher Maths, Unit 1, NAB, and it's outcome 3. That's the differentiation section. Okay, so 3 questions to answer. Questions 8, 9 and 10. We're going to look at the first one. So find dy by dx when y equals 2 all over root x. Okay, let's do that one first. Right, question 8. Okay, we're starting off with 2 over root x. Okay. And I can't differentiate that at the moment. Can't differentiate whether I've got roots on the bottom or x on the bottom, so I'm going to try and prepare that first of all. Okay, so I'm going to change it to index form first of all, and what I have there is I've got root x will go to 1 over 2, which will just give me a half. That's because the x is to the power of 1 and the square root is just a 2 that's sitting there, although we don't usually show that. Okay, so I've changed it to index form. And the next thing that I'm going to do is I'm going to move this to the top line, okay? And I'm going to move that from there. I'm going to change it to 2x to the minus a half. Okay, the reason why that really works is because this part here, what I have is 2 all over x to the power of a half. The 2 really looks as though it's got an x to the power of 0 sitting there, just because remember that x to the power of 0 is equal to 1. Okay, so and that's why I can get that to be 2x to the minus a half. 0 minus a half gives me the minus a half. Okay, so I've now got that prepared, and what I'll do now is I'll go ahead and differentiate it. So dy by dx is going to be equal to, so it's going to be minus a half times the coefficient of x, which is 2, x to the power of, and I'm going to reduce that power by 1. Okay, so that's going to take me down to minus 3 over 2. I'm going to gather the bit up at the front, so minus a half times 2 will give me minus 1x to the minus 3 upon 2. And that's my answer there. Now the way this is going to be marked, it's going to get 2 marks for question 8. The first mark is going to be when it is prepared correctly and ready for differentiation. And the final mark when we differentiate it correctly. 2 marks, okay? So question 9. Let's have a look at what question 9 was asking us to do. So question 9, find the gradient of the tangent to the curve y equals bracket x minus 1, close bracket, bracket x minus 2, at the point A, 3, 2. Okay. So let me show you what that question is really asking us to do. So the first thing it's really asking us to do is based on the curve that we have here, and this curve here is y is equal to x minus 1, x minus 2. Okay. So it's asking us to find the gradient of the tangent to the curve at the point A, where A is going to be the point here, which is the point 3, 2. So my x coordinate is 3, my y coordinate is 2. The gradient at that point there should be a straight line that should be running through something like that there. And really for that line I'm interested in finding out the gradient. Okay, so I'll show you how we do that. Okay, so first of all I'm going to start with the equation of the curve. And I'm going to prepare that. Okay, so I'm going to multiply the brackets out by FOIL. I'll multiply out the lasts, multiply out the insides. Oops, sorry, the firsts, the outsides, the insides, and the lasts, and that should give me a plus 2 there. Gathering together the middle terms should give me x squared minus 3x plus 2. I can then go ahead and differentiate that now. So differentiating is going to give me 2x, okay, 2 times the 1 that's sitting in the front here, which gives me 2x, reduce the power by 1, which gives me 2x to the power of 1. Just write it like that. This here will go to minus 3, 1 sitting there, that'll give me minus 3x, and that'll be to the power of 0. And x to the power of 0, as we mentioned up above, is equal to 1. And the 2 will go to 0, because that is starting with an x to the power of 0. 0 times 2 gives me 0, so there'll be nothing left there. Now what I have here is dy by dx. Now that really is also a way of working out the gradient. That's one of the main reasons that we do differentiation. we differentiate to find a gradient equation. Okay, so that's the gradient equation there. So for any value of x, I can substitute it into here, and what that will tell me is, that will tell me what the gradient is going to be. The point that we were working with is the point A, which was 3, 2. So I'm going to substitute my x value into here, the gradient equation, and that should tell me what my gradient is. So I'm going to substitute a 3 in, where I see x. It'll give me 6 minus 3, so that there gives me a gradient of 3. Okay, and again, that's the final answer to that question. So this is a 3-mark question. We'll get 1 mark for knowing to differentiate, so just for knowing to do that. So dy by dx is equal to will give me a mark, and for getting the 2